Get them.
Good morning, all. Monday, March 7, 2022. Lightweight today. Lunch, mainline chicken nuggets, hot cheese milk, and cheese sub, crispy salad, Spartan grill, pork fritter, or Bosco dip.
For those who choose the factoring route, this is factorable without splitting terms, as is right now.
Tuesday during lunch. Tuesday for all food participating drama trip. Menu will be free. Use party time packing and other important information. The final trip meeting for those going on the break trip is today at 5 o'clock in the A's room. Today at 5. Both students and parents need to attend tonight. Contact me again with questions. Seniors, another week or so. Vote for the graduation speaker. That closes on March 16. Into next week. Junior class and senior class. Make sure you look at the scholarship database. Lots of them listed. Some do begin during the junior year if you want to check out. Seniors are maybe added again over the last week. Seniors also cap and gowns delivered to high school next Monday, 11 a.m. to 12:30. And any other items that you order as well, you have to have the balance paid before you can pick those up. Next Tuesday evening at 5:30 before the pop concert. Fine Arts Boosters, we have Music Matters dinner. Nacho bar. Admission $5. $20 for entire family. Come enjoy a night of musical entertainment, food, art, in the art. Here in the art show, sponsored by the Syracuse Math Opera House. Interested in that, contact Mr. Howard Municipal. Athletes, make sure you apply for the senior athletes for the Sport LA Booster Club scholarships is now available in activities office. Also, any seniors, if you think you are a Regent Scholar, make sure you stop by the guidance office to verify your name is on the Regent Scholar list that will be submitted to the South Dakota Board of Regents coming up. Being interested in healthcare, deadline for application for the scrub camp to be held in Spearfish is March 7th. Make sure you get that in today. Interested in scrub camp, held at Rapid City Joy Center, you have to register by today. Rivers High School debate teams, 7th consecutive team South Dakota State Championship. We had co-state champions in public forum, Allie Radenberg and Howard Phelan, Max Enser and Katie Jones, state champion in oratory. Max Enser, a state champion in informally speaking, Howard Phelan, a runner-up. In informally speaking, Hallie Radenberg, runner-up international extemp, Stan King. Third place, Phoenician extemp, David Gooch. Third place in U.S. extemp, Will Becker. Fourth place, Lincoln Douglas, Sam King. Fifth place, U.S. extemp, Katie Jones. And sixth place, Sophia Del Forte. Quarterfinals, Lincoln Douglas, David Gooch, and also team members bringing home the trophy, Clayton Donovan, Maria Eisenbraun, and Donald Werner. Congratulations again to the debate team representing Spearfish High School in such a great manner. All please stand for the pledge. To the flag. And to the republic for which it stands, one nation, under God, indivisible, with liberty and justice. All have a good day. Great.
I'll just hand these out now. Given how many of us are taking time with them. I sent the text out last night, if you bothered to look at it, that it doesn't make sense for us to split 2-5 on either side of a test day. This is one of those times where you don't see, oh, Sullivan sent something, swipe. Okay, everyone got one? Who's still going on this? A couple of mutters. Okay. I have to mute Wordle on every social media platform that exists. People are obsessed with that game. Okay. Anyone still? Okay. If you're going to go the factoring route, you look for quadratic form. In this case, 3x to the fourth, 10x squared minus 8 is in quadratic form. Negative 5x to the third minus 20x, also quadratic form. Okay, you just rearrange it. Where it gets a little iffy is when you have to split a term to make that happen. Okay, there's algorithms for it, and the more I thought about it, I've always just done it by mental math, but there are algorithms you learn for it in Calc 1 and 2. So for now, we can do this because it is factorable by grouping. The only way you're making a 3x to the fourth is with a 3x squared and an x squared. If you have to go full AC method on it, factors of negative 24 that add up to 10 are positive 12, negative 2, split, what do they have in common, all that kind of business. Or if you can mental math your way through what factors of negative 8 right here and here are going to give me a 10 in the middle. And again, it's 4 and negative 2. Here these have a negative 5x in common, leaving a x squared plus 4. I see they have an x squared plus 4 in common. If I take that out, I'm left with a quadratic again. 3x squared minus 5x minus 2, which itself is factorable. This is sum of squares, x plus 2i, x minus 2i. This is, again, if I've got a prime, it's fairly easy to mental math your way through it, or you go full AC method on it. Factors of -2 that are going to get me to a -5 in the middle are -2, +1. There's my linear factorization. If I don't do the factoring method, then instead I write out 3, -5, 10, -20, -8, and say, I feel really lucky about 2, 6, 1, 2, 12, 24, 4, 8, done. I feel really good about a -1/3. Getting 3, -1, 0, 0, 12, -4. Okay. You recognize the irreducible quadratic. We've talked about this before. There's a reason there's a 3 here, is because this just said x plus 1/3. You notice that wasn't actually one of my zeros, or one of my linear factors. So either I leave it like this and then have that 3x squared plus 12 that I will then factor, or I remember, oh wait, I'd have to divide this by 3 to make this a 3x plus 1. And now this is x squared plus 4. Okay, so either way, whether you put the 3 into this binomial or leave the 3 in this binomial, to get the full linear factorization, you're going to have to deal with that 3 at some point. Okay. Did anyone have this, but you did have the 3 taken out? You had 3 x plus 1/3, x minus 2, x plus 2i, x minus 2i. Anyone go that route? Okay. So whether you factor, just straight up factor, or whether you do synthetic division and then deal with the irreducible quadratic at the end by sum of squares, either way, you should end up at, I will take yellow or red. Okay. It does say as a product of linear factors, so technically red is wrong, but I'll take it because it's fully factored, if you went that route. And this one, because you had 2 different ways to do it, and they both involved a lot of missing parts. Missing parts? Moving parts. There we go. Words are hard. Did you know what? We're going to go Likert on this one. You 100% got to either yellow or red. You got the work to back it up. You came close, but maybe goofed up something with that 3. You really biffed something on the factoring, but you have those zeros. You have the zeros, you weren't really sure what to do at the end, or you just wrote the zeros and didn't have the factors at all. You just solved and quit. You've got 1 or 2 of the zeros and then you just stopped. Didn't even know what to do with the rest. Or left that as x squared plus 4, not going any further at all to solve or find the factors. You at least tried. You didn't even try. Okay? So we'll go Likert scale on this one because depends on your method. You had in class on Friday, you had Spartan time on Friday, and you had the entire weekend, one question. 2 if we count early this morning. Speak now or forever hold your pieces. Yeah? Okay. If I know those zeros, go ahead and find the polynomial that made them, I'm assuming. First of all, covered this several times in the video. Sometimes they just tell me the conjugate. You don't have to do it twice. Okay, this is going to be a quartic, not a hexic. I don't have to say 6 minus root of 5, 6 plus root of 5, 6 plus root of 5, 6 minus root of 5. They just told me the conjugate for this one. So if I know 6 plus or minus root of 5, and I know 8 minus 3i, again, the way the book wants us to do it, the way that every book I have ever seen, Algebra 2 and PreCalc, do it, is x minus the 0. X minus the 0. X minus the 0. X minus the 0. So it's conjugate. Distribute your negatives and then go distribution bonkers on it. It's going to take up half your page. Maybe a full page if you just got big handwriting. That's the way they want us to do it. But every math teacher worth their salt in Algebra 2 shows kids, wait a second, I don't have to do that. I've got a cheater. The cheater says, if I have just a radical, the quadratic that made it is x squared minus 2ax plus a squared minus b squared. If I have a radical, but it happens to be an I, when I distribute everything, there'll be an I squared that changes this sign. So it's x squared minus 2ax plus a squared plus b squared. I would much rather use that cheater form because I know that any time I have these conjugate roots, this is what they're going to do. So instead, I'll say x squared minus 2ax plus a squared minus b squared times x squared minus 2ax plus a squared plus b squared, whomp. And I will plug in for my radical, a and b. A and b. For my imaginary, a, b. Now remember, whether it's going to be a positive 3 or a negative 3, whether you're using 8 minus 3i or 8 plus 3i, it doesn't actually matter, because the only time that b occurs is when it's getting squared, so the sign's going to end up positive anyway. This tells me I don't really have to do all of bleh. Instead, x squared minus 12x, 36 minus 5 is 31. X squared minus 16x, 64 plus 9 is 73. I might need some help because I doubt my mental math is up to it after the past week. Distribute. X squared times all the stuff. X to the fourth minus 16x to the third plus 73 x squared. Negative 12x times the stuff. Negative 12x to the third plus 160, 32, 192 x squared minus 730 140, 876. And then 31 times the stuff is 31x squared minus 310, 180, 496. And nope, not doing it. Okay, maybe 2100, 31, 2100, 900 is 3000, 3073. Damn. Okay, what is it?
2,260.
Wow, Samsonite. 2263. Okay. And combine like terms. X to the fourth minus 28, x to the third plus 5, 6, 16, 19, 20, x squared minus 2, 1, 9, 7, 1, 12, 13, 72x plus 2263. This part right here of distributing a quadratic into a quadratic, that multiplication, you have to do it 2 more times to get these into these quadratics. That cheater is so helpful because it eliminates, in this case, almost 2/3 of our work. It's also a matter of slowing down and watching your signs, watching your arithmetic, maybe double checking some of that mental math. Just poke it in a calculator to be safe. Okay, there were only, what, 4 or 5 problems? Because they were big. They had a lot of oomph to them. Okay. Review, you notice this time you only got 5 problems. I actually had the chance to speed run it this morning, so it'll actually fit, even for our slow pokes. Back half of 2-3. We had long and synthetic division. Those are kind of incorporated in what we're doing with 2-4, so that's why there's not as many problems. Also, they're a little more involved. If I want to know if something is a factor, then I'm going to divide and see if my remainder is 0. So I can divide however I choose to divide. Since those are linear factors, I'm guessing we're not going to do it longhand. 1, 3, -4, -30, -36. I'm about to do division on a problem on a test. What's a note that I should write next to this? Placeholders. Don't get got. Don't have it get you just because you missed a placeholder. Check for them. So I'm going to start with -2. Get -2, 1, -2, -6, 12, -18, +36. Hey, it works. If the first factor works, then I'm just going to keep going with the quotient set. If it doesn't, then I'll start over with a new one. Say 3 by 1 is 3, add 'em. 3 by 4 is 12, add 'em. 3 by 6 is 18, and lo and behold, it works. That doesn't always happen. Sometimes only one of them works, sometimes neither of them work. So I now have 2 factors that work. I don't know if you can tell that it's in italics because it's a single letter, but write a factored form. a factored form, not the factored form. So you don't have to keep going. You can just say x plus 2, x minus 3, and then what's left, because I've taken a quartic and reduced it 2 degrees, is x squared plus 4x plus 6. Okay. Now the difference between, again, a factored form versus the factored form. If I ask for the factored form, you'd have to keep going. This is all it's asking for here, but just to review. Complete the square. Half of 4 is 2. 2 squared is 4. This is x plus 2. The quantity squared is negative 2. Solve by square roots. If I were to write the fully factored form, I'd have to replace this with x minus negative 2 plus I root of 2 x plus, minus negative 2 minus I root of 2. Okay, it'd be gross. If I had to go all the way to linear factors, because those two linear factors have complex roots, they would just stay ugly like that. Okay, now you don't have to go to orange, yellow, done. Okay? But, got to review when it's relevant. Next up, describe the possible real and rational zeros. So, stage 1. How many possible real zeros are there? 4. Purely because it's a quartic, fundamental theorem of algebra. But it says to describe them. So I can take that down further and tell you which ones are going to be positive and negative. With Descartes' rule, the possible positive real zeros, I put in a positive x and count the sign changes. We got positive, negative, 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 negative. There was only one sign change, so there's only one possible positive real root. For negatives, possible negative real roots, I'm going to plug in a negative x. If it's an even power, signs won't change. If it's an odd power, signs will change. Even power, signs won't change. Odd power, signs will change. Even power, because constant is x to the 0, 0 is even, won't change. And I count up my sign changes. How many? So we go down in pairs. There's 3 or 1. What if there were 5 sign changes? 5 or 3 or 1. If it was 4 sign changes, 4 or 2 or 0. Always down in pairs. You're doing a review right now that looks just like the quiz you're about to take. Write notes on there. Tell yourself. Go down in pairs. Can't go down from 1. Don't write 1 or 0, because I can't. 1 to 0 is not 2 zeros. It's not 2 roots. Okay, I'll see that every now and then. Next up is possible rational zeros. It's plus or minus all the factors of your constant over all the factors of your leading coefficient, or your leading coefficient. 1, 2, 4. Maybe another note to yourself, because every now and then I'll see kids who just leave it like this. Don't leave it like that. Write them out. Now, you can still get kind of lazy and put the plus minus out front instead of writing it a whole bunch of times. But you do still have to write out what the actual terms are. It's 1 over all this stuff. 1 over 1, 1 over 2, 1 over 4. It's 5 over all this stuff. 5 over 1, 5 over 2, 5 over 4. Okay? Or you could do 1 and 5 over 1, 1 and 5 over 2, 1 and 5 over 4. It doesn't matter, you're still writing them. Don't repeat them. If there's ever something that gets repeated, say that was a 1, a 5, and an 8. Well, 8 over 4 is 2. If I already have 2 earlier on, don't write it. Okay? Don't have to say it more than once. So, number 2, crap. Number 2 is tell me about the possible zeros. Number 3 is find all the zeros. So, find all the zeros. Negative 20, negative 8, negative 2, 25, 25. That one's factorable. See Kira back there like, no, ain't doing it. It doesn't say how to find the zeros. It just says find the zeros. Okay, before I go putting it up there, does anyone want to see the factoring way? Okay. So, the factoring way, I look for quadratic form. 4x to the 4th minus 8x squared minus 5x, or minus 5, minus 6x to the 3rd minus 3x. You see if I just rearrange it. Here, I know this is something x squared and something x squared. I also know the only way that I'm going to get 5 is with 5 and 1. So if you got the mental mojo to do a quadratic where a is not equal to 1, go for it. If you need to go full AC method, also go for it. Whatever you need to do. But I see a negative 10 and a positive 2 will add up to negative 8 in the middle. I've been doing this since 1998. Okay? Unless the sleep deprivation is just that bad, yeah, you can do it in your head. If you have to go full AC method, 4 times negative 5 is negative 20. Factors of negative 20 that add up to negative 8 are negative 10, positive 2. What do these have in common? What do those have in common? Do the full AC method if you need to. Over here, I see they got a negative 3x in common, leaving x squared plus 2x squared plus 1. They both have a 2x squared plus 1 in common, leaving me with this quadratic. Again, if you have to go full AC on it, 2 times negative 5 is negative 10. Factors of negative 10 that add up to negative 3. Split your term. What do these have in common? What do those have in common? Go for it. Or 2 is prime, as is 5. There's only so many combinations. If you got the mental gas for it, I'd say a negative 5 here, a positive 1 there. Okay, or if it's not mental math, I know, what was it, last week I saw someone was doing The diamond method, I know Miss McCreary's fond of that one. Box method is basically the same thing. Whatever your jam is, use it. This one, you know how to factor it? It is sum of squares, they're just ugly. It's square root of 2x plus I square root of 2x minus I. Square root of the first one, square root of the second one, going to be i's. Another option for it is take a 2 out, x squared plus 1/2. So then it's x plus I square root of 1/2, x minus I square root of 1/2. The reason I don't like that is don't leave it as a square root of a fraction, because now you have a square root of a 2 on denominator. You need to rationalize it. So it just says to solve it. Could I right here say x is 5/2, x is -1, solve by square roots? Times square root of 2 times square root of 2 is square root of 2 over 2 I. Okay. So method 1 says you factor. Method 2, the kid who's been sitting there for the last 5 minutes saying, why am I doing this? No, I don't want to. Just go synthetic. -6, -8, -3, -5. Say, I feel really lucky about -1. 4, -4, -10, -10, -18. Wait a second. -1? Did I miss a placeholder? -6. Oh, okay. Whew. I was like, no, that ain't right. +2, -2, -5, +5, gone. Say, I feel really lucky about 5/2. Half of 4 is 2. 2 times 5 is 10. 0. 0, 2. Half of 2 is 1. 1 by 5 is 5. 0. And now I have 4x squared plus 2 equal to 0. Solved by square roots, get same thing. Okay? So whichever route you take, either factor completely or synthetic division until you get to a quadratic, deal with the quadratic. I'll tell you that based off of my test bank questions, I usually reverse engineer these. I start with the zeros, multiply them together to make the polynomial. You're probably going to have some form of either compound or complex zeros at the end where you can't just look at a calculator, write those two, and be done. Keep going. Okay? Backside. Use the given 0 to find the rest of the zeros. Well, if I know 2 plus root of 2 is one of them, I also know 2 minus root of 2 is one of them. If I know both of those are zeros, I could, again, x minus the thing times x minus the thing, go distribution bonkers on it, or get that cheater out, x squared minus 2ax plus a squared b squared. Is it going to be plus or minus? I heard both. Argue.
So there's no I.
minus because there's no I. So I'm going to have x squared minus 2ax plus a squared minus b squared. A is 2, b is square root of 2. Be careful when you're dealing with that b term. It's the entire radical. I don't really know a good way to say that. It's the radical term. So if that was 3 root of 2, I would put the entire 3 root of 2 in there, not just the root of 2. Okay? Whatever the radical term is. So I get x squared minus 4x. 4 minus 2 is 2. Into x to the fourth minus 6x to the third plus 27x squared minus 72x plus 34. And I long divide. X to the fourth divided by x squared is x squared. X squared times the stuff is x to the fourth minus 4x to the third plus 2x squared. Change my signs. Getting negative 2x to the third, 25x squared, drop it, little hot, negative 72x. Take negative 2x to the third divided by x squared to start the process over again. Getting negative 2x times the stuff. It's negative 2x to the third, 8x squared minus 4x. Change my signs. Getting 13 words, 17. 17x squared minus, 68x plus 34. Ew. All right, I hope this last one works. Maybe, could be, chance of, theoretically, possibly. 17x squared divided by x squared is 17. 17 times the thing is 17x squared minus 68x plus 34. Change my signs. Whew. Close. Again, I reverse engineer this problem. It will work. If you do long division and you get a remainder, you screwed up. Okay? It will work. But now, I've got a quadratic that I have to solve. I'm going to do it by complete the square because I'm going to do that all semester long, and we're going to hit chapter 7, and those of you that have been doing quadratic formula this whole time, and then you have to do complete the square twice in a problem to figure out the conic, you're going to go, oh, I should have done it the other way. It's coming. Negative 2x, I'm going to add that, or subtract 17 to the other side. Half of negative 2 is 1. Add 1 squared, so 1, to both sides, getting x squared minus 2x plus 1 is the quantity x minus 1 squared. Negative 17 plus 1 is negative 16. Solve by square roots. X minus 1 is plus or minus 4i. Add 1 over. Make sure that you answer the full question. If you know one of the roots, find all of the roots. 2 plus or minus root of 2. 1 plus or minus 4i. Notice that there's a lot of room on this back page. There's only 2 problems because I know some of you write gigantic. Okay? Also notice with only 5 problems, if it's still out of 30, that means each problem is going to be worth a little more. These ones on the back, because of all those moving parts, I'm giving you credit for each stage of the process. Don't just get a little unconfident partway through and quit. Run it all the way to the end zone. Even if it's the wrong end zone, hey, good on you. Okay? I can check through your work And I can see that you did everything right, you just missed this negative back here. Okay? Run it all the way through so I can give you all those points for the steps of the process. Okay? Write out the steps of the process. Tell yourself, use cheater, make quadratic. Step 1. Step 2, long divide. It will work. Step 3, quadratic formula on what I get. Okay, tell yourself how. And then, write a polynomial of least degree with integer coefficients that has these as zeros. Just like our daily quiz. You probably don't want to do the double distribution thing. It's really gross. It takes forever. If that's your jam, go for it. I can follow it. But most of us are going to use x squared minus 2ax plus a squared b squared times x squared minus 2ax plus a squared b squared. Contestant 1, a squared plus or minus b squared? No I, minus. There is an I, plus. Because that I squared at the end of it will change that sign. So, all right, x squared minus 2a x plus a squared minus b squared. X squared minus 2ax plus a squared plus b squared. Womp. And I plug in there. A and b are 2 and square root of 3, respectively. A and b are 4 and negative 5, respectively. Write this one out. This is x squared minus 4x. 4 minus 3 is 1. X squared minus 8x. 16 plus 25 is 31. And then distribution bunkers. I hope the way that I've been distributing these makes sense. I like to keep the like terms lined up like that. It helps the organization. That's my jam. If you want to, has anyone been doing the Punnett square style with these? Okay, where it's 1, 2, 3 columns, 1, 2, 3 rows, fill in the boxes. It works. Okay, it all depends on how you feel about it. So, 16 and 25. Oh no. I'm surprised I made it this far before the mistake. Y'all,
It's still pretty.
that doesn't count twice. Thursday, Friday, goblin number 1 had double ear and eye infection because he was digging in his ear and then rubbed his eye. Yep. And yesterday I was puked on 3 times before lunch by goblin number 2. It was something. So that's a 41. X squared times the stuff. No, yellow. Is x to the 4th minus 8x to the 3rd plus 41x squared. Negative 4x times the stuff is negative 4x to the 3rd plus 32x squared minus 164x. 1, 2, 3. 1 times the stuff. Well, that one I can do. Combine like terms, this is why I distribute it this way, because everything's nice and lined up. I know where my like terms are. My function is x to the fourth minus 12x to the third. That's 73, 74. X squared minus 172x plus 41. And if I want to check that, let's say you got some time. You finish your quiz, you get to the end, you look up at the clock, you're like, I got 12 minutes. Cool. You can take that and now long divide it with either one of those quadratics. It should get you the other quadratic. Okay? You can always check them by working backwards because each of these problems was created by working backwards. So, if you would please, devices to the counter, mix yourselves up. There's some of you I've seen getting a little too free with where your eyes are during daily quizzes and quizzes. So please mix yourselves up. And you will have 48 minutes to do with what, by my count, should be under 28. Okay? You should have plenty of time. Mix yourselves up. And again, make sure that you have your notebooks and stuff turned in today. I did not get through them last time. I want to get through them today during second and third block and after school.